Bismillahirrahmanirrahim. Dear students, hope all are fit and fine. And today we discuss about chromophore and auxochrome. So let's go. Definition of chromophore. That's mean chromophores are the functional group compound of molecule which are responsible for the color of molecules or compound. That means any groups which exhibit the absorption or electromagnetic radiation in UV visible region is known as chromophore. Example, the nitrobenzene. Here nitro group is a chromophore. Now types of chromophore. Here two types of chromophore. Chromophore with pi electrons, and like the all kind of unsaturated compound, like double bond or triple bond. Here the acetylene, propylene, or ethylene, those are the pi electrons, the chromophores. And the chromophore with pi and n electrons, that's when the compound which actually carry the lone pair electron, available lone pair electron, like the carbonyl compound, acid groups, ester, and etc. And now the auxochrome. Auxochrome, it is a group which itself does not act as a chromophore, but when attached to the chromophore, it shifts the absorption maxima towards the longer wavelength and increase the intensity of the absorption. That means it's not a chromophore, it's just increase the intensity of the absorption or shift the lambda max to the longer wavelength. And here ways NH2, OR, NHR, and NR2, that's etc. the auxochrome. And the condition for this auxochrome groups contain the lone pair electron, should be lone pair electron. And here we can say the benzene, the aniline, and only benzene lambda max at 255 nanometer. But when our auxochrome NH2, the amine group attached to the benzene, and the aniline lambda max at increase, and the lambda max shift toward the higher wavelength at 280 nanometer. And the all auxochrome have one or more lone pair non-bonding electron, that's mean lone pair electron. Auxochrome actually how that's mean auxochrome exhibit the shift where lambda max to the longer wavelength, as well as the increase the intensity of the absorption maxima. Here we can see the lone pair electron, and also is the mandatory condition for the auxochrome, and this lone pair electron take part in conjugation, and for this reason the lambda max or intensity of the absorption will be increased. That means conjugation is the fact for auxochrome. Here the another example, and the acid group, and this acid group contain the carbonyl group as well as OH group, and here OH group is auxochrome, and this OH group contain lone pair electron, and this lone pair electron take part in conjugation, and by this conjugation auxochrome increase the absorption maxima, and the lambda max shift towards the longer wavelength. Now a spectral shift or shift in the absorption maxima, that's the lambda max. And now the bathochromic shift or red shift. And absorption maxima and the lambda max shift towards the longer wavelength because the presence of the certain groups such as OH, NH2, that's been auxochrome, or by solvent. And when lambda max shift to the longer wavelength and is called, and this phenomenon is called bathochromic shift or red shift. Suppose lambda max of benzene the 255 nanometer, but when N is to attached to the benzene, the lambda max shift at 280 nanometer. That's mean here the lambda max shift towards the longer wavelength, and that's why it's called the bathochromic shift or red shift. Sometimes without auxochrome, two or more chromophore if attached or add or contain organic compound, it's also increase the intensity maximum absorption intensity, as well as shift lambda max toward the longer wavelength. Here we can see the ethylene lambda max 170 nanometer, on the other hand 1,3 beta diene lambda max 217 nanometer. That's meaning here additional chromophore present in this compound. Now, hypsochromic shift or blue shift, absorption maxima shift toward the shorter wavelength. That's mean this may be due to the removal or conjugation or charge in solvent. Suppose the aniline here N is 2 in the auxochrome and the lambda max of aniline 280 nanometer. And when this aniline take absorption or absorbance in acidic medium, the aniline NH2, this in the base part, take part in a reaction with the acid and destroy the conjugation or conjugation ability of auxochrome, and that's why the lambda max shift toward the shorter wavelength and is called blue shift. Now, hyperchromic effect, that's mean the increase the intensity of the absorption is known as the hyperchromic effect. When increase the intensity, here we can see the intensity of the absorption, and in the presence of auxochrome or any other solvent effect, the increase the absorption maxima, and this is called the hyperchromic effect. And the hypochromic effect to decrease the intensity of the absorption is known as the hypochromic effect. Another, due to the presence of group which can destroy the geometry or conjugation, and that's why we can see the hypochromic effect. Another spectral shift or shift the absorption maxima at a glance in a picture. If the lambda max shift toward the longer wavelength and is called the bathochromic shift, and on the other hand it's shift toward the shorter wavelength, that's mean the left side, and is called the hypsochromic shift. And when the lambda absorption maxima and the intensity of the absorption maxima increase, and this is called the hyperchromic effect. And when absorption maxima decrease, the intensity of the absorption maxima decrease and is called the hypochromic effect. Now, effect of solvent in electronic transition or solvent effect. For the alpha beta unsaturation carbonyl compound show two different shifts for N to pi star. In this transition, the absorption band moves to the shorter wavelength by increasing to the polarity of the solvent. That's mean in nonpolar solvent, the alpha beta unsaturated carbonyl compound, the N to pi star transition energy and the delta E1. And when this compound placed in the polar solvent, and the polar solvent create a hydrogen bond with the alpha beta unsaturation carbonyl compound, and that's why the ground state orbital will be stabilized, and the in energy difference between the N to pi star will be increased. The energy will be increased. That's why lambda max towards the shorter wavelength, lambda max towards the shorter wavelength. On the other hand, here in the example, the absorption maximum of acetone in hexane is at 279 nanometer, but in water, here the water is the polar solvent, and the lambda max decrease and at 264 nanometer. And the another effect, pi to pi is the transition in alpha beta unsaturation compound. In this transition, the absorption band moves to longer wavelength by the increasing the polarity of the solvent. And that time, and if the in at a non-polar solvent, the alpha beta unsaturation corporal compound pi to pi transition energy delta E is and delta E is less than, and when this compound, that's when alpha beta unsaturated carbonyl compound take place in the polar solvent. In here, by the hydrogen bonding in with the polar solvent, in the pi to pi transition, the ground state pi orbital as well as pi star orbital both are stabilized, and here delta E2 del E2 is the short or lesser than del E1. That's when the lambda max shift towards the longer wavelength. Here the energy the decrease. So this is the solvent effect for alpha beta unsaturation compound, and this is the picture. And now criterion for the selection of the solvent for UV visible spectroscopy, and it should not itself the absorb in the region of investigation. That means absorption will not occur. As well as the solvent, it should be pure and it should be cheap. And so many solvent we can see in the right side, the water to carbon tetrachloride maximum, and the most of the time the lambda max, the lambda cut off nanometer 200 to 265 nanometer. In the case 95% case, for UV visible strategy, ethanol is widely used in the solvent for this analysis. And thank you very much. That's all for today's. And again, we can see in our next class. Thank you, my dear students.